Hello everybody, welcome back. Today in Module 1 we're going to be talking about types of variables and levels of measurement of those variables. Variables are characteristics or qualities that have at least two values. For example, height has many values. Therapy, type of therapy, group therapy, psychotherapy, aquatherapy, etc. You have different types of therapy. Constants, on the other hand, are the opposite of variables. They do not vary. They stay the same. Scientists examine the effects of variables on one another at a time, one at a time in experiments. So an experiment has at least two variables. It has what's called an independent variable and a dependent variable. Those are easy to get confused. I'll try to help you remember. An independent variable is the factor or characteristic in an experiment that is manipulated by the researcher. And by manipulated, I just mean changed. It's the one that has more than one value assigned to it. So, for example, whatever type of therapy you are given, that is the independent variable. It's the presumed cause in our cause-effect relationship that we're studying in our experiment. The dependent variable depends on the level of our independent variable, or the treatment group that people have been given. It is our measured outcome. It's the effect that we're interested in. So, for example, if we're interested in the effect of a certain drug on decreasing depression, then drug or treatment condition, drug or placebo, that's our two levels of our independent variable, is our independent variable, our causal variable, which we think is going to influence or create changes in the depression level, which is our dependent variable, or our measured outcome of interest. Excuse me. So another couple of examples, if I think that fear causes people to affiliate with one another, then fear is my independent variable. I can either make people afraid by doing all kinds of things, coming up behind them and going boo, or telling them I'm going to shock them severely, or a number of things, telling them they're going to fail at class, the fear condition or no fear condition. And then I can measure affiliation to see if they want to hang out with other people or if they want to, in fact, be by themselves after being scared. Fear would be the independent variable. Affiliation or being with others would be the dependent variable. Another example, if I think that passionate love is caused by someone's physical attractiveness, then the independent variable would actually be the level of physical attractiveness of the person, high, medium, or low, for example, depending on how I want to define that. And the measured outcome, or the dependent variable, would be passionate love, or the feeling that I have about someone. So the causal variable is the independent variable manipulated by the researcher. The independent variable is the cause. The dependent variable depends on the independent variable if the relationship works. Okay. So there are a couple of other things to know about variables, and there are other kinds of variables we will talk about later, but those are the two main ones that you need to try to remember now. And they sound very similar, so it's easy to confuse them. Variables can also be either discrete or continuous. Discrete variables can't be broken down into smaller units at all. They're things like number of siblings, and you just can't have half a sibling. But continuous variables can be broken down into smaller and smaller units. So something like time, you can break that down into minutes, seconds, milliseconds, nanoseconds, and as small as we can measure. So it can be broken down into smaller and smaller units. So those are two aspects, or two types of variables that we can look at. When we're looking at our types of variables, we need to consider whether it's a discrete variable or a continuous variable. And that'll come in handy later when we start talking about statistics. Okay, now the next thing we need to talk about, so independent variable, dependent variable, discrete and continuous. The next thing that we need to talk about is levels of measurement, or sometimes called scales of measurement by your textbook. if we're going to look at relationships between variables, which is really what's fun about research, this part is not so much fun. But when we want to answer questions, which is what's so cool, if we want to do that, we have to measure our variables or manipulate them. And if we're going to manipulate and measure our variables, we need to know what level of measurement we want them to be on, or that they already exist on. So there are 4 scales of measurement: nominal, ordinal, interval, and ratio. And those are actually in order, where each one builds on the other. They add a quality each time to make it a more sophisticated level of variable each time. So the first one, nominal, is only categories. It's only names. That's why it's called nominal. So if we have shoe brands or names of stores or a student ID numbers, those kinds of things are not in any kind of order. They simply identify different categories. So nominal is the most basic kind of measurement. Ordinal scales take those categories and put them into some kind of order. So like a ranking, first, second, third place in race, for example. So if you come in second in a race, you may just know that you got the silver medal, but you don't know by how much you lost that race. We don't know the milliseconds or the seconds by which you lost to the first person, but you know that you came in second. So you do know the order, but you don't know how much space is between each of the categories. Now, interval level takes that ordinal scale where we have ordered categories, and it adds to it equal-sized categories. So now we have equal units of space between our measured categories. So for example, now maybe we know how much time there was between that person who came in first and the person who came in last. Although it's not the best example, it's more of a ratio level. But we'll get there in a second. A good example of an interval level variable is the Fahrenheit temperature scale. Because while we have individual units that are equidistant from each other, like 1 degree, 2 degrees, 3 degrees, 5 degrees, 7 degrees, we know exactly how far apart each degree is from the others. And they are in order, and they also have their own names, so they qualify for all of these. It also has an arbitrary 0 point. That means that the 0 on the scale does not really mean actually 0 or none. It means something arbitrary. So on the Fahrenheit scale, we know that, at least for us, 0 is, us in Florida I should say, 0 is very, very cold, but it doesn't mean that there's no temperature. Okay, it just means that it's very cold. So it's an arbitrary number. Now ratio scales, and ratio and interval are often used kind of interchangeably because so many variables, they resemble each other in a lot of ways, and a lot of the statistics could be used in the same ways, the two of them. Ratio level is the same thing as interval, except that it has a meaningful 0 point. And by that, I mean that the 0 actually means that there's none of something. So, for example, temperature on a Kelvin scale is technically considered a ratio level variable because at 0 on the Kelvin scale, the molecules actually stop physically moving. And so there is now a point at which 0 is a meaningful thing where there is no longer movement. So compared to Fahrenheit, where 0 is just really cold, in Kelvin, 0 is meaningful. Frequencies are another example of a ratio scale. You can have none of something, like you can have no cookies or no siblings. So anytime you can have 0 of something, and it really means 0, then you have a ratio level variable. Now the complicated thing to remember is that the way that we measure a variable is, especially thinking about the ratio variables, is that it's more of a theoretical thing than an actual thing. So for example, time and weight and distance, length, all those things are ratio level variables. What ratio level variables do for us is they essentially act like interval variables, but they also have that meaningful 0 that allows us to speak in terms of ratios, to speak in terms of saying things like he's half as tall as that other guy, or he's twice as old as this person. So we can speak in those terms. That's what it gains us. And in psychology, it's not as important often to make that distinction, which is why we sometimes treat these similarly in our analyses. But so, for example, on a yardstick, even though no one can be 0 feet tall, there is an end to that yardstick, and so when it ends, there is actually a point on the measurement instrument where there is a 0. And if there's a 0 there, then that means that the 0 is meaningful. So even though you can't actually find someone who is 0 years old, time, like the stopwatch on a watch, can actually be at 0 before you press start, and then you now have an actual 0 point, which is why it's considered a ratio level variable, even though you won't ever find someone who it takes 0 seconds to get from one place to the other. Even Sonic or other superhero people that you might encounter. So hopefully that explains the types of variables that we're interested in for now. There are going to be many more later, and the difference between discrete and continuous variables, and finally our 4 levels of measurement. We're going to practice these a lot in class. I just wanted to give you an introduction to them: nominal, ordinal, interval, and ratio. And I hope to have lots of questions about these next time. Like I said, we'll be practicing, and you guys will all be feeling really confident about this by the time we're done with this. All right, thanks guys. Appreciate your listening.